All right, guys, let's do some solving exponential and logarithmic equations. So your exponentials and logarithms are inverse functions, and they're also inverse operations of each other. So a couple weeks ago when we needed to solve those exponentials where we had time as our exponent, and we used the calculator, but now we can look at how to use logarithms. Your notes here say, yes, of course, we can use insolve on our calculator to help. You can go to menu, algebra, numerical solve, and you can type in the entire equations like you see them here. Be sure to do comma, the variable that you used. For all of these are x, so you could do comma x, close it out, solved, bam. And that's the way I would coach you to do it on EOC or benchmark when you're in a timed test setting, but I know a lot of you want to know how. And I know it's important when you go to Delta Math, if you miss it and you see all their work there, a lot of you want to know what that all is. So I'm going to model a couple of problems here using the calculator, of course, but I also want to show you how. So that you can learn a little bit more about logarithms if you wish. So let's look at number one. We're going to use some of those logarithm rules from the last lesson about how to condense this. Notice on number one, our logarithms both have bases of 7. So on this second one, you've got that 2. I'm going to move that to my exponent. So I'll have logarithm base 7 of 7x plus logarithm base 7 of 6 squared equals 3. Then I can also combine them into a multiplication, 6 squared being 36. So log base 7 of 7x times 36 equals 3. Log base 7 of 252x equals 3. And then from here, I'm going to change it from a logarithm to an exponential equation. So remember, you're going to have your base of 7 will still be your base raised to the third is equal to 252x. So just taking it from a logarithm form into the exponential form. Let me slide up a little bit, give us a little bit more room. 7 to the third is 343. Ooh, 252x. So I have 343 equals 252x, and just finish solving for x. Divide both sides by 252. You're going to get a lovely 1.3611111111 repeating equals x. And I think on Delta Math, you want to leave that in fraction form. So just simplify down your fraction to 49 over 36. So not a beautiful answer, but it was a logarithm equation. So, all right, so that's the by hand way, by hand. Now let's go check out the calculator. All right, so here's my calculator. I'm going to open a new document. No, I don't need to save. Add calculator. We're going to go to menu, algebra, solve, numerical solve, and type in this whole equation. So I'm going to do control logarithm of base 7 of 7x. Whoops. Arrow over. Of 7x. Arrow out of that. Plus another logarithm, base 7 of, forgot my 2. Let me go back over here. 2 logarithm, base 7 of 6 equals 3. Do not forget, comma, we used x. And enter. 1.36111111, which is what I wrote over here. And then I changed it to a fraction. Now on Delta Math, it will accept your decimal form. If you have any troubles with that, let me know. So working it by hand is going to give you the exact fraction from the solving process. Let me show you. Because remember, we isolated here. We isolated x, and we just had a simple division of 343 divided by 252. Simple fraction, easy to reduce into fraction form, which is where I got that, just using a basic calculator. But if you use nsolve, it's always going to give you back that decimal form. It's a little tricky to get it to turn into a fraction. So again, Delta Math should accept your decimal form from using nsolve on your calculator. All right, let's try the next one. I'm going to do this one by hand. If you want to be a calculator person, be a calculator person, okay? But here's by hand for all my friends that want to know more about their mathematics. So let's see, we just have our subtraction. So I'm going to change this to division log base 2 of, I have 8x over 7 equals 4. Again, I'm going to change this now into exponential form. Now that I've condensed it down as much as possible, I've got base 2 to the 4th is equal to 8x over 7. I think I chose this problem on purpose because it's a little messy. So 2 to the 4th, check my notes here, is 16. So you have 16 equals 8x over 7. Start solving. From here, it's easy peasy. Times 7 gives us 112 equals 8x. Divide by 8. X equals 14. So that one's not so scary. Okay. So again, if you want to go and hit that up on the calculator, it should give you 14. Easy peasy. Do a calculator page, menu, algebra, numerical solve, type your entire equation the way you see it, including the equal sign, comma, x, parentheses should be closed, and you should get a whopping 14. So that's part 1 of your Delta Math homework. So let's move on to the next type. All right, solve for x rounding to the nearest hundredths. So watch your directions there. I think all of them are hundredths, but double check me on that. So 2 decimal places, looking at the third to tell me how to round the second decimal place. Number 3 says 10 to the x equals 93. So what we can do is use logarithms. So we're going to take the logarithm of both sides. So I'd have log of 10x equals log of 93. Remember, math rules say I can do whatever I want to an equation as long as I do it to both sides. So I did this because we have a logarithmic rule that says that exponent can come to the front. Extremely helpful here because my whole issue is that I do have a variable as my exponent. So let's move that in front and have x times log of 10 equals log of 93. Now I'm trying to get x by itself. So divide away log 10 on both sides. So that x is by itself. And now I'm just going to go and do log of 93 over log of 10. Now, it's a log with an understood base 10, so I can use a little baby calculator. I can use my phone calculator if I want to. As long as it's a log base 10, you can use some of these more simple calculators. But I'll go over to the Inspire and show y'all. I'm going to type that in. All right, so I do have division of 2 logarithms. So just to make sure my calculator knows what I want, I'm going to make the 2 fraction bars doing control division and put in the top log. It's understood base 10, so I'm going to leave this blank and put 93 and move down, control log, leave it blank. You can put in a 10 if you want to. It's not necessary. And enter 1.96848. 848. We're rounding to the nearest hundredth. So I want to round this place, but I look at the third decimal place, the thousandths decimal place to tell me that it is 1.97. The 8 says rounded up. Number 4, again, we can go straight to the calculator, type the entire equation in the calculator and be done. If you want to be a calculator person, you can do that. So on this problem, we're going to up the ante a little bit. I'm still trying to solve for x, and x is stuck to e. So before we do anything, let's isolate things a little bit closer. Divide both sides by 51. So if you have a coefficient in front, see if you can divide both sides by it so that you have something like e to the x equals 10. That's much better. All right, so let's take the logarithm of both sides because I have a logarithmic rule that says if I have an exponent, I can move it to the front. And I'm trying to get that x. So I need him to get out of that variable spot. So I'm going to take a log of both sides. which means now I can move the x in front. And now it's easy to isolate x. Divide away this log of e from both sides. All right, let's see. X equals, I can hit up basic calculator because it's still base 10s. I'm going to go ahead over to the Inspire and put log of 10 divided by log of e. All right, again, because I'm dividing, I want to make sure the calculator knows what I want. So I'm going to make those two fraction boxes. Log of 10, oops, not base 10, leave that blank, over log of e. Now, if I hit enter right now, it's going to give me a syntax error. If I don't put an exponent there, I just want e to the first. I don't really need anything else. And enter. 2.30259. It looks like my calculator actually rounded a little bit there. So round to the nearest hundredth. So I'm going to look at the 2. The 2 says rest 2.30. So number 5, doing some of the similar things. I've got an issue with my variable is in my exponent. I don't have any coefficients I can divide away. So let's just go ahead and take the log of both sides. And use that logarithmic rule to move my exponent to the front. And then we are trying to isolate x. So I can divide away the 3 and the log of 10. I'm going to do that at the same time if that's okay with y'all. So we'll have x on the left, and I'm going to go hit up the calculator to divide these. Make my fraction boxes. I've got a log of 98 over 3 log of 10. Oh, of 10, not base 10. Enter. 0.663742. We are rounding to the hundredths place, so the 3 says 2 rest 0.66. Number 6 looks very similar actually to the last one. So I'm going to divide away this 8, which I know is not very exciting because it gives me 1 over 8, which if you want to write 1 over 8, you can, or that's 0.125. Whichever you prefer. So now I'm going to use logarithm of both sides to get my exponent free. So that the exponent can come in front. 3x of log 10 is equal to log of 0.125. Again, getting the x by itself. So you can divide away the 3, you can divide away the log of 10. And then I'm going to go ahead over to the calculator and type this in and see what we get. I'm going to make my fraction boxes. I'm going to have control log of 0.125 divided by 3 times the logarithm of 10. Enter. Negative 0.30103. Rounding to the nearest hundredths, the 1 says rest. Perfect. And again, all of these, even these next ones that are super scary, you could type the entire thing into InSolve if you want to. So you could have turned me off a long time ago if you wanted to. But I know a lot of you want to know the mathematics behind it, and that's why we're doing these completely by hand. Number 7. So I purposely chose this one for our notes because it's a big hot mess. The section on Delta Math that this is under has a lot of easier ones. This one is literally the hardest one out of the ones that came up. So first of all, we want to isolate it a little bit more. So add 3 to both sides. I mean, you've got an exponent with a fraction. Ugh. Let's go ahead and take the log of both sides. Okay. Zoom out a little bit here. All right, so now I can move the exponent to the front. The x over 10 plus 4. Might even want to put parentheses around that so you can see. So I'm still working to isolate that x, and it's in my parentheses. So I'm going to get rid of that extra log of 3 with some division. Isn't it messy? It's so messy. So I'm going to go to my calculator. I'm going to get log of 4.7 divided by log 3. Have some kind of decimal answer. We'll subtract 4 and then multiply by 10. We'll do all those extra inverse operations. So control my fraction boxes. I've got control log of 4.7 divided by control log of 3. Enter. Beautiful decimal, 1.408 something something 65 equals x over 10 plus 4. So what I was saying, once we get this decimal, now we're just going to finish our inverse operations. The 1.408 minus 4 is negative 2.5913 and times 10. Slide this up a little bit, will give us negative 25.913. Nearest hundredths, looking at the 3, tell us what to do. Negative 25.91. Let it rest. Final answer. The last one, number 8. He's hiding up here. Again, you can throw it all into InSolve if you want to, and it will just shoot out an answer. So some of y'all are going to have your work done in 2 seconds on Delta Math. Let's look at this one. So on number 8, you have to, if you're going to solve this by hand, we have to have same bases. So whether I'm talking about bases with exponents or my logarithms with bases, remember those are the same. Whether it's an exponential form or logarithmic form, the bases, the term base means both things and they serve the same place and they have to be the same. Okay, so if I have 16 raised to the equal to 256 raised to the, they both need to be the same number. So whether they're both 16s or they're both 4s, I need to find a common base that they're equal to, like change it to 4 squared, which is 16, also raised to the x plus 1. Let me use it that way. Okay, so is there a way to rewrite 256 with a base of 4? Okay, so you can go to, you can think about your logarithms, that I want a log base 4 of 256. What would be the exponent? You can do it that way. And you can check to see if it's 16. It is going to be 4. You can do the logarithm, you can guess and check, but it is 4 to the 4th is 256. And then power to power rule. So all I did was change them to the same base. You have to do that before you move forward. All right, now that our bases are the same, I can actually start to clean up some things. I can actually do some things with my exponents here. I'm going to actually distribute those across. I'm going to keep my bases the same. You got to have the same bases on these. And have 2x plus 2. And same thing over here. I'm going to distribute these across and get 4x minus 4. Once your bases are the same, then the exponents can be set equal. So 2x plus 2 is equal to 4x minus 4. I don't even need to worry about what the bases were. They were already equal. So now I can continue to solve for x's that were just in my exponent. Now it's a variables on both sides. I'm going to subtract 2x from both sides. Get 2 equals 2x minus 4. Add 4 to both sides. Get a whopping 6 equals 2x. Running out of room. Divide both sides by 2, and we have 3 equals x. Now, what just happened? Well, you can, if you were like, wait, what? Remember, our backup method is just throw it all into InSolve and use the calculator to solve the equation for us. But what we did is we changed the bases so that they were the same. Once your bases are the same, then you can set your exponents equal to each other and solve. So big deal, these bases have got to be the same. So our original problem was 16 and 256. So I made them both bases of 4 raised to the exponent to make them equivalent. It could have been 16. You just kind of have to guess and check on those. So that's the way to do those by hand. There's all your work by hand, but literally every single one of those could be solved with your calculator using InSolve. And guys, on your benchmark on EOC, that is exactly what I want you to do. We ain't got time for this mess when we can quickly solve it on the calculator and move on to a question that I can't use a calculator for, that I have to do by hand. So keep that in mind, guys. Reach out if you have questions. I'll be glad to help.